Okay, there we go. So today's kind of a continuation of what we did yesterday. It's just adding, nope, that's geometry. Measuring and adding angles is not what we're doing. There we go. Sorry about that. Function symmetry, and then even and odd functions. So we're adding one more way to analyze functions and graphs. So we're going to be able to determine what kind of symmetry it has, if it has any symmetry at all, and determine if a function is even or odd. So if you've got stuff to take notes with, go ahead and grab that. I'm going to get a piece of paper and we'll get started. And this is still 1.2. Monday we'll be getting to 1.3. 1.3 is involving things like continuity. Where'd the green pen go? There it is. Uh, 1.2 symmetry and even or odd. Okay, and you'll be happy to know today's assignment is shorter. So that'll give you some time to finish up with the others if you were not able to finish those. The first thing we're going to talk about today is symmetry. And you've probably seen graph symmetry before. There are 3 types. Okay, so the first type is symmetry with respect to the x-axis. Okay, so symmetry with respect to the x-axis. So if the x-axis is a line of symmetry for the graph, that means it is symmetric with respect to the x-axis. So for example, we might have something like this. This is the equation for this would be like x equals y squared. You type that into Desmos, that's what you get. And then there's kind of, you can visually inspect, and kind of tell if something has symmetry, but you can also tell based off of like a XY table. So for this particular one, if I have the table for it like this, when my x value is 1, my y value is either 1 or -1, right? On this, because -1 squared is 1 and 1 squared is also 1. Then for my x values of 4, it would be 2 or -2, right, for the y values that go with it. So if you've got this relationship here where you have x and y values, and then also the same x value with the negative y value that corresponds with it, that would give you the idea that it has x-axis symmetry. This is kind of the rule to tell if something has x-axis symmetry. If this point is on your graph, then this point is also on your graph, in order for something to have x-axis symmetry. Okay, so that's symmetry with respect to the x-axis, and then we also have symmetry with respect to the y-axis. That's the second type. Okay, so symmetry with respect to the y-axis is going to be if you could use the y-axis as a line of symmetry for your function. So for example, if we had like y equals x squared minus 2, parabolic functions, if they're not shifted left or right, typically have y-axis symmetry. be at -2. And so you can tell if you look at the graph, you can kind of visually inspect, or you can use that same idea with the t-chart from before. So when x is 1, y is -1. When x is -1, y is also -1. When x is 2, y is 2. If I plug it in here, 2 squared minus 2 is 2. When x is -2, y is also 2 again. So that would kind of correspond around maybe there for those 2 points on your graph. So the idea here is that in an when it has symmetry with respect to the y-axis for your function, you've got, if this is a point on your graph, then the negative version of x with that same y value is also a point on your graph. So they kind of have this opposite thing going here. If it's symmetry with respect to the y-axis, then each x value goes with positive and negative y value that corresponds there. And then when you've got y-axis symmetry, you've got a point, and then you've got the same point with the x value with the opposite sign. Okay. The third type of symmetry is going to be symmetry with respect to the origin. So we haven't seen that kind of symmetry yet. Neither of these also have symmetry with respect to the origin. But symmetry with respect to the origin is going to look a little bit more like rotational symmetry here. If you think back to geometry when you learned about rotational symmetry, or advanced algebra trig when you learned about symmetry with functions, that's kind of what we're looking at here. So symmetry with respect to the origin we would see in things like y equals 1 over x, where we've got a function that looks like this. Okay. Sorry, my mask is, and all the geometry notes all over my desk are in the way. Okay. So then we have same idea with the chart going here. And you can tell based on the chart if we know what we're looking for. So we're going to make a rule for this as well. So for example, in this one, if I plug in 1 for x, my y value is 1. If I plug in -1 for x, my y value is -1. If I plug in 2 for x, my y value is 1/2. If I plug in -2 for x, my y value is -1/2. So I could keep doing this, right? And going, okay, if I plug in the positive x value, I get a positive y value that goes with it. If I plug in a negative x value of the same type, I get the same y value, just the sign's changed, right? So the rule for this one is if I have this point as part of my function, that coordinate, then -x, -y is also represented by my function. So that's the third type of symmetry. And when we talk about symmetry, we also like to talk about things like functions being even or odd. So when a function has respect to the symmetry with respect to the y-axis, we would consider that to be an even function. And you might have heard before, like in advanced algebra trig, like if both of the arrows on the ends point up or both of them point down, that tells you that it's an even function. And generically, that is true unless the function is shifted around, in which case it's then not considered an even function. And then same thing goes for odd functions. Odd functions are symmetric with respect to the origin. So when we, in advanced algebra trig, probably talked about not polygons, geometry, get out of my brain. When we talk about polynomials, the other poly that we care about in math, we talked about how, odd polynomials will have arrows on the ends that point opposite directions. So generally that's true as long as the function isn't shifted around. But this kind of broadens our definition of what an odd function is, because it does have arrows pointing up and down, but it also has asymptotes and things like that and isn't covered under the definition of a polynomial. So odd functions defined as having symmetry with respect to the origin. Even functions defined as having symmetry with respect to the y-axis. And that is everything that is new today. So looking at that, do we have anything on there that doesn't quite make sense? Anything we want to go back over or anything like that at the moment? And just as always, if you do at any point, type in the chat or unmute yourself and say something. Okay. I'm going to go and get the assignment going real quick. Today's assignment is going to be a worksheet. And it's not a real long worksheet. But hopefully that gives you a little bit of time then to finish up with things like the Khan Academy stuff, and make sure when you're doing the Khan Academy ones that you log in. Otherwise, I can't see what you've done. And where'd the worksheet go? Here it is. All right. So jumping over to Google Classroom here. Refresh the page, and hopefully it shows up. There it is. Okay, here's our worksheet for today. It's going to go just like the other worksheets that we have done in this class, where you upload a picture or a PDF of your work when you're done. You can print out the worksheet and do it on there if you would like, or you may do it on your own paper and turn it in, or you can make a copy of this PDF, turn it into a Google Doc and type on it if you would like. Whatever you would like to do, whatever you know how to do is fine. But this is kind of a review of what we've done so far in 1112. So for the first one, we want to estimate the values using the graph, and then so plugging in those x values and figuring out about what they would be, and then actually plugging them in and solving it algebraically. We're finding domain and range for these ones. We're finding the y-intercept and the zeros here. And then for these, we're figuring out symmetry. What do they have symmetry with respect to? Support your answer numerically. So like, show me with the t-chart, what do you think? Do we think that it has symmetry with respect to the x and y axis and the origin, or none of those? And then for 7, graphing using a graphing calculator. So you can use a Desmos or you can use a TI calculator. And then analyze the graph to decide if it is even, odd, or neither. And if it's even or odd, describe the symmetry that we've got going there. Confirming algebraically, I'm going to go over that really quick as well. So we'll add one more thing to our notes real quick here. How we would show algebraically that something is symmetric. Let's do that. I'm going to grab another piece of paper. And we're going to use that same, come on. Don't fall. Sorry, there's things on my desk that, yeah, like the mic. All right. Confirming. Symmetry algebraically. I think I spelled that right. Algebraically. Well, hopefully that's the correct spelling of things. All right. So let's say I wanted to confirm with respect to the origin. We'll just use this one, for example. Another way to say this in function notation is to say that f of negative x is equal to negative f of x. F of negative x is equal to negative f of x. So if I wanted to show that this has symmetry with respect to the origin, I want to show that if I plug in negative x for my x value, I get negative f of x for my, like what it comes out to be. So the first thing I kind of want to do here is figure out what I'm starting with and where I'm going. So let's say we were doing it with f of x equals 1 over x. I would want to then show that f of negative x, well, what is f of negative x? F of negative x is 1 over negative x, right? I would want to show that this is equal to negative f of x. Well, negative f of x is negative 1 over x. Those are the same thing, right? 1 over negative x is the same thing as negative 1 over x. So I would want to show that those two things end up being the same. And sometimes it takes a little bit more doing to show it. So I will show another case where it takes a little bit more to show it. Also, for even functions, we would be showing that f of negative x is equal to f of x. So it's another thing to add to your notes there real quick. And we're not going to hugely emphasize confirming symmetry algebraically, but it is something that's nice to know, and it's good practice with manipulating functions. So let's say I was doing f of x equals x cubed minus 2x. So first thing I would probably do to figure out what kind of symmetry we're looking for here is plot it on a graph. So I would go in my calculator and go x to the third power minus 2x and take a look at it on the graph. Okay, so just by looking at it, I don't see any lines of symmetry. So I would say that this is, likely to be an odd function. It's likely to have symmetry with respect to the origin. So if I was going to look for that, we would do kind of what we did up here. So figuring out, okay, what is f of negative x? Well, that would be negative x to the third power minus 2 times negative x. Okay, so any negative number to the third power is still negative. So I can remove the parentheses here and say that this is going to be negative x to the third, and then negative 2 times negative x would be plus 2x. Okay. So I'm going to leave that for a moment and figure out what I would end up with if I had negative f of x. Oh, yep, sorry. So negative f of x would be just like negative times the entire thing, x to the third minus 2x. So if I distribute this through, the negative, because that's, kind of like having a -1 out front, I would get negative x to the third, and then -1 times -2x would be plus 2x. Since these two things are the same, I have showed that f of negative x is equal to negative f of x. So usually if you just kind of plug it in and work it out and see what you end up with when you simplify, you can show that those two things would be the same. Okay. Let's see. I think that's... I will show one with an even function real quick, because even functions, we're going to look for f of negative x to equal f of x. And that, yeah. Okay. So last example here, we're going to say f of x equals x to the fourth plus 2. So if I go in and graph that, x to the fourth plus 2. And we go and take a look at the graph. So just looking at my different types of symmetry, that looks like it has symmetry with respect to the y-axis. So to confirm it algebraically, we want to show that f of negative x is equal to f of x. So I'm going to figure out what is f of negative x. Well, that would be negative x to the fourth power, because you're just plugging in negative x anywhere you have an x, plus 2. But then anytime you have something negative to the fourth power, does it stay negative or does it become positive? What's anything to the fourth power, no matter what? Positive, right? Yeah, anything that's negative, if you put it to an even power, it becomes positive. Anything to an even power, no matter what, is positive, unless you're dealing with complexes, but that's different. Any real number to an odd power, if it's negative, will be negative. So odd powers, they keep the sign. Even powers, it's positive. So in this case, that's the same thing as saying x to the fourth plus 2. But wait, isn't that what f of regular x is? Yeah. So that's enough to show that f of x is equal to f of negative x, because those are the same. So this would tell me that we have, it's an even function and that it has y-axis symmetry. This is enough to show me that this function is odd and has symmetry with respect to the origin. Okay. Any questions at the moment? Any numbers that don't quite make sense? Steps we're not sure why we did them or anything like that? Okay. Well, if you do have questions, please stick around. Otherwise, you have time now to work on your worksheet. Towards the end of class, I will post an exit ticket, but you are free to go and get working on that. I'll be on here the rest of class if you need help or anything.